Hello again, this is Engineer Louie Alcarde from Midas IT Philippines, and now we are on the second part po ng ating um, Gen Application 1 tutorial, which is the loading applications. And we will now begin. We now go to our load tabs, and sa static load cases naman, we will create our static load cases first. The first one we will call self. Type is a dead load, and of course ang description po nito, it's a self weight, and click on add. The next is a dead load. Description din po nito is of course dead load, and type dead load. Click on add. Name the third one as live load, and change the description to live load. Click on add. Lastly, WX. Not the last one, but wind load on structure. Description po nito is wind load in X direction. Click on add. Lastly, WY, which is wind load naman on Y direction. And we click on add. Now, all these 5 static load cases are all here, which are yet to be assigned. So we close this. First, we will assign the first one as the self weight. Load case name is self. We will just put -1 on the Z direction, so that on the Z direction po ang application ng ating self weight. Click on add, and as we can see, we have a static load case 1, which is defined already here. And after that, now we will define our floor loads. The first one we will name as shop, dead load, and live load. For dead load, we will put -3.6 and -3.9 naman for the live load on our shop, kilonewtons per square meters. Click on add. The next one is going to be called office. Still load case, dead load, and live load, but this time with a different factor. The dead load is 4.2, and for live load naman, it's gonna be -2.5. And then we click on add. Lastly, we will put our roof load as well, and same pa rin po, we will change the factor to 5.1 for dead load, and -2.0 for live load. And then we click on add. Now those are yet to be assigned pa po, so they are not reflected here yet, but they are going to be reflected there after we do this, after we assign our floor loads. Now for the first floor load type that we will assign, it's gonna be first of all, we have to activate it by story. Below lamang po, and we activate that. So this is the area that we will be working on for this application or for assigning our floor load. Distribution is going to be one way. Now we will have floor loads with different applications. We will have floor loads that has 3 subbeams, 1 subbeam, and 0 subbeams at all. So they're different, all different. The first is we will have 3 subbeams. So maglalagay tayo ng 90 degrees on angle, 0 on angle A1. 3 subbeams. A2 naman is 90, and we'll put self weight 0.883 kilonewtons per meter. This one we will copy on this times 5 meters on the Z direction, because we also want to copy the floor loads that we assign here in our third floor. So upon clicking nodes defining loading area, we will now apply the loads here. We can just begin here. First, we just have to check the floor load name and floor load area for that, para po makita po natin yung application ng ating floor loads. There you go. Then we'll have another one in here and another one in here. And this one as well. And the other two naman dito sa baba. Okay. Now after making sure that all those are applied, we will now go to the other one with one sub-beam. So one sub-beam, the angle, same pa rin po. Still, copy this on the third floor. Notes defining loading area. We will be loading these floor loads in here, in here, in here as well, and lastly the two areas here. Now last but not the least, we will have one with 0 sub-beams and 0 everything. Still copy that, but this time it's gonna be here and here, and lastly in this little area in here. There you go. So after making sure that all of those are applied, we now activate the next floor that we want to apply our floor loads to, which is the 4th floor. Activate that, and that's the 4th floor. Now this time we will apply the office load type. One way pa rin po siya. We will copy the floor loads on 6 at 3.8 and 5 at 4.2. For 3 sub-beams, we will have A1 as 90. So number of sub-beams 3. A2 is 90 and unit self-weight is 0.883. And then we apply those loads in these areas here and here. Next is we will assign floor loads with 1 sub-beam. Copy pa rin po natin sila sa dito naman po na areas. There you go. Okay, last but not the least, everything with a 0. So 0 sub-beams, 0 angle, and 0 self-weight. Ito po siya, yung maliit na area dito. And there you go. Now after making sure that all those are applied, let's uncheck copy floor load, and we will apply the loads naman sa ibang areas. First is we will have 90 again here, 3 sub-beams with 90 angle 2 and 0.883 in this one. Saan po ba natin sila i-apply? Dito po ang first. the other one dun sa taas. Oops. You have to make sure that we are clicking the right node in order to apply. In order to apply the loads correctly. Then the next one is with only one subbeam. So another 0 here. One subbeam, 90 and 0.883. Ito naman po sila. That and that. Okay, so after that we have applied those, we will now activate the other one, our 5th floor. Activate po natin siya, and we can close this. For 0 subbeams naman, 0, 8, 2, and 0 unit weight. Self weight. We will be applying this and copying this particular floor load dun po sa taas. So because we are already in our 5th floor, babawasan po natin ng isa. And where do we apply this? Dun po sa maliit na area. Ng ating 5th floor. There you go. You see that they are already applied, and we can now proceed to our roof. Activate our roof. Active. Close this. Roof, one way, and for 3 subbeams, again, this is 90, 3 subbeams, 90.883. We don't need to copy it anymore, so let's just apply the load already. 3 subbeams there, and another 3 subbeams in here. Pardon. Now for one subbeam naman, for only one subbeam, this is 0, 1 subbeam, 883. Most defining loading area, ito po siya. And this. Now for the last one with everything 0. Lahat na po sila dito sa gitna. Lalagyan na po natin ng floor load. Okay. And last but not the least, huwag po natin kalimutan itong maliit na area dito sa labas. There you go. So we are now done with applying our floor loads. Pwede na po natin silang i-off. And then we can also check the floor loads dito, the table. So I will leave you to check it, whatever you want to check within this table. If there's something important that you want to see, then you can go ahead and check it. After naman, we go back to our control data, and we will join a story. Sa auto generation of story data, we will change 15% of plan dimension, gagawin po natin 0, and click OK. So that's that. We will now go to loads. When loads, we click on add. WX, ang gagamitin po natin dito is UBC 1997. Huwag po tayo ma-confuse because this is as suggested dun sa ating tutorial for application 1. And we will be using a projected area method here with exposure category C, 80 miles per hour, importance factor 1, we'll change this to 1.3. Because this is only x direction, we will only consider a scale factor in the x direction, which is 1. Click on apply. And lastly, WY, and we only have to change the scale factors. And click OK. So we do have our wind loads already. And we can close this. Now we can go back to our structure tabs and click on structure type. Para po ma-define natin ano yung ating structure type, we will go to structure type, which is 3D. Lump mass po ito, and we will convert self-weight into masses. And also, we will align top of beam section with floor. XY plane for panel zone effect. So, after doing that, and we can now click on OK. Here. And next is we will convert our loads to masses. Mass direction po is going to be X, Y only. Now for dead load, we will have a scale factor of 1. Click add and click OK. Now, we can now go to our query, and ito po yung ating story mass table. If you want something from it, if you want anything, any information that is of use to us, we can check that in our story mass table. This is everything, the level, translation mass, rotational mass is also here. Of course, center of mass on X and Y coordinates. They are all there. And we can close this, go back to our model view. And let's now proceed to, since we are done with our static loads, we can now go to our dynamic loads this time. Now, sa dynamic loads naman, we will first have our response spectrum load cases. Check po natin yung eigenvalue analysis control. Eigenvectors pong gagamitin with subspace iteration. 15 frequencies po, number of frequencies is we will use 15. We will leave everything as it is, number of iterations to be 20, subspace dimension to be 1, and conversions tolerance 1E-010. And we can click on OK. So after that, we go now to our modal combination control. Click on ... We want our modal combination type to be SRSS, and just click OK for that. And after that is we will now go to our RS functions. To add our RS functions, we will check our design spectrum using UBC 1997, checking automatic for seismic coefficients calculation option. And soil profile type, we will be using SA and zone 1 for seismic zone factor. And we can just click on OK and check in here our spectral data. So if you want to check that out, and click on OK. Close po natin ito. Now for the load case name dito sa spectrum load case, I will name the first one Rx, xy ang direction, excitation angle will be left to 0, scale factor is 1, and period modification factor is 1. We will check UBC 1997 and we will add our load case, which is this, as reflected in this as well. And another one, y naman this time, ry, but this time excitation angle is already 90 degrees. Ganun pa rin po ang scale factor and period modification factor. And add. So we have two cases for our response spectrum load cases here. After that, we can close this. So after making sure that we have added our static load cases and dynamic load cases, they are all in here if you want to check them. Meron po tayong self-weight, static load case 1 is self-weight, yung dead load natin, live load, wind load on X and wind load on Y. And sa response spectrum analysis naman, we have UBC 1997 and case 1 RX and RY for case 2. And of course, we can see here that we have considered eigenvalue analysis in this particular project. So after making sure that all is there, we can now perform the analysis. Now this is the part where we can check that we have everything that we have inputted is correct, because magra-run po yung analysis. Now if sa modeling part pa lang po na nagkamali na tayo sa pag-identify ng ating SRC columns and steel columns, that will be problematic in performing the analysis. So this takes longer than it should. Okay. Now after performing the analysis, we are now ready to go to our design, but it will be discussed later after in the next video. So again, thank you so much for watching, and I hope to see you again in the next video. Have a good day.